Section 3.6 is all about solving radical equations. What I'd like you to do is start off by writing down these three key steps, and they'll guide you through pretty much solving any type of radical equation we can throw at you guys. The first step is to isolate the radical. So get that term that's being raised to either a rational exponent or the term that's got a radical sign by itself. The second step is to raise each side to a power that's going to eliminate the radical. The key is here not to forget the plus or minus sign if it's an even root. Just like when we were solving quadratics, if you took a square root of both sides, which is an even root, we would use a plus or minus sign. And then the last step is to solve the remaining polynomial equation. If you're lucky, it's a linear equation. If it's not so bad, it might be a polynomial like a quadratic, and then potentially even a higher degree one. But for you guys, usually either a linear equation or a quadratic. We're going to do one example to kind of give you a little bit of a taste for what this section is about. If you look at this example and do it with me, the first step is to isolate the radical, and I'm going to identify this term here as my radical since it has that rational exponent. So what I'm going to do first is I'm going to add 1 to both sides of the equation, so that radical is isolated. That'll cancel with the negative 1. And now I have x plus 2 by itself raised to the 3/4, and that's going to be equal to 8. Now, we're ready for step 2. What I have to do is think to myself, I want to raise both sides of the equation to an exponent that will eliminate the power of 3/4. So essentially what I'm doing is I'm thinking, what do I multiply 3/4 by so that it will become 1? So I know that if I multiply by the reciprocal, it'll be 1. So the power I'd like to raise both sides to is going to be to the power 4/3. If I raise this side to the 4/3, I have to raise the other side to the 4/3 as well. What you do to the one side, as always, you have to do to the other. Now when I do that, 4/3 times 3/4, they cancel, and I just get x plus 2 alone on the left. On the other side, I have 8 to the 4/3. Now this is where I have to be careful. I have to be careful if I'm taking an even root, I have to use that plus or minus. However, if you take a look closely here, remember the denominator of your rational exponent is the root. This is an odd root, and I don't need a plus or minus sign for an odd root. There's always exactly one odd root. So what we're going to do is basically simplify 8 to the 4/3 power. Now I know I don't need a calculator to do this one. It so happens that I can change this into 8 to the 1/3 power raised to the 4th, that's still raised to the 4/3. I'm just going to apply the third root, or the cubed root of 8 to that first, which I know is 2. And then I'm going to raise 2 to the 4th, giving me 16. Now, on the left side, I didn't mess with that. That's still going to be just x plus 2 the whole way down. My last step, though, is to subtract 2 from both sides. If I do that, I get x equals 14. Now, it would be pretty easy to check if we were to plug that 14 back into the original equation to show that we get a true statement there. But for the time's sake here in this video, I want to make sure that you're able to just spend your time now practicing the following problem. So I'd like you to see if you can isolate the radical term and then solve this thing. If you have a little time, see if you can plug it back in to see if you get 375 equal to 375, just to verify your answer coming in tomorrow. Good luck, and we'll talk about it more tomorrow. Thanks for watching.